Right. We've been executing our statements and performing various operations on the data that we have available through vectors and matrices, but that's not sufficient in creating a computer program. So we're looking in this section at the flow of information through our programs, and we want to apply a certain prescribed set of logic to create the kind of output that we require. So we will need for the program to effectively make decisions or to follow our decision-making pattern that we program into the computer. So just to give an example of what I mean there, we would like for the computer to be able to take a decision or to execute a set of statements based on some criterion. So for example, if there's a certain course, let's call it course B, and if course A is a prerequisite to that course B, then a student can't take course B unless he or she has passed the course A. So that simple statement is quite easy for a human being to understand. If course A is a prerequisite to B, and if I fail course A, then I can't take course B. But there are several components to that we have to be able to codify before a computer program can act on it. So as part of that, let's look first at what we call condition statements. So a condition statement allows for us to check a criterion. So the first question in answering this kind of logic is, has the course been passed or not? So in computer programming, the output or the outcome to a criterion like that is a true or a false. Is the condition true? Has it been met, or has it not been met? Equivalently, we assign these values to it. So if it's true, then it has a value of 1. If it's false, it has a value of 0. So Boolean algebra is the branch of maths in which we effectively associate our logic with numbers, and we use operations on those numbers to determine the logic behind our process. And so the operators that are important there are these ones. So here the angled bracket here is x greater than y. Is x greater than or equal to y? Right, in maths we're used to writing that as that greater than sign with just a small line beneath that, but of course we don't have a keyboard key for that, so we write that in computer programming as greater than or equal to y. Similarly here, is x less than y, is x less than or equal to y? And then here you see a double equal sign, right? There is these are two equal signs that are just written after one after the other. So this is the question: is x equal to y? And then there's another one here: is x not equal to y? So that exclamation mark or symbol, that means not. Right? We'll see in Matlab that the syntax for a not is the tilde. Anyway, let's try to write some code around this now. So switching over to Matlab, let's just clear that screen and let's create the variables x and y. So let's say x is 40 and y is 60. Then we ask, is x greater than y? So the answer is 0. 0 we said is false, right? X is not greater than y. 40 is not greater than 60. So the result is false. Is x less than y? Right? We expect that to be a true. And yes, we get the answer 1 there. So x is indeed less than y. Is x equal to y? Right? And x is not equal to y. 40 is not equal to 60. So that's a false. Right, now you see why we have to use the double equal sign there. Right, if we said x equals y, and we know that y has a value of 60, then x is going to become 60. Right, so we need to distinguish between a condition, right, a comparison. We need to distinguish between when we're trying to compare two values as opposed to when we're trying to assign a value to a variable. So those are our comparators, And we can use that to create extremely complex or extremely sophisticated logic statements. Right, so in the example that we looked at, we were asking, has the student passed course A or not? And if the criterion for passing a course is that the student achieve at least 50% for that course, then this is the check that we'd perform. Is the course mark for course A greater than or equal to 50? So that operation, the result of that operation is going to be stored in this variable outcome here. So if outcome is 1, that's true, we have passed the course. If it's 0, it's false, we have not passed the course. So that seems quite elementary, but we can use that to ask quite complex questions. So taking something slightly more difficult than that, we can ask if this course has two prerequisites, namely courses X and course Y. We want to know whether course X and course Y have been passed. So if the two have been passed, then we would want the student to register for course Z. So we can do this using the AND operation. So the AND has the effect of checking for us whether both those conditions have been met. So we can ask the question here, is the course mark for X greater than or equal to 50? And is the course mark for Y greater than or equal to 50? So if both these are true, then the outcome of this complex statement here is true, right? So if the course mark is greater than or equal to 50, then that's a 1. And if the course mark for Y is greater than or equal to 50, then that's also true, that's a 1. So 1 and 1 return for us a 1. In other words, this is overall true. So let's write the associated code for that. So let's create in the command window, let's clear that. Let's say X is equal to 40 and Y is equal to 60, so that's what we had before. And we can ask the question, is X greater than or equal to 50 and is Y greater than or equal to 50? Now this AND operator here in Matlab is given the syntax, this is the syntax for that AND operator, this ampersand. So here X greater than or equal to 50 and Y greater than or equal to 50. In other words, if both these conditions are met, then we are allowed to register for course Z. So you can see here it says no, don't register for course Z. That's because you failed course X here. So if we reset that, let's say we force X to have a value of 50, then the result of this check is that indeed both X and Y have been passed. And so it says, yes, true, we can register for course Z, right? If on the other hand, let's say X was 60 and Y was 40, and we checked our condition again, then although this side of the criterion was met, Y was not more than 50. So this was a 0, that was a 1, and so that would return for us a 0 over there. And of course, if we had not passed either one of those courses, let's say we had 40 and 40 for the two courses, and if we executed that statement, then neither one of these would be true, and so overall the statement is false. So you can see also that the effect of the AND operator is to multiply together the two values. So if this is true, that's a 1. If that is true, that's also a 1. So 1 times 1 is a 1. So the outcome there is true, it's a 1. If this is false, in other words, this is a 0, and this is true, that's a 1, then 0 times 1 is 0. So one of those conditions is false, so the outcome is a false. If on the other hand, this was true and that was false, then that's 1 and 0. 1 times 0 is also a 0. And if they're both false, it's 0 times 0, that's a 0. So mentally, in the same way that we're trying to convert a statement like this to a 0 and a 1,